All right, welcome to this webinar, Hypermedia Authentication API, mobile attestation on iOS. Some of you are perhaps new to our Hypermedia Authentication API, so we will go through what it is and how this works. And we will also go through a recap of what we mean with mobile attestation against this Hypermedia API. So if you have seen the Android version of this presentation that we had last month, you will recognize some parts. However, if you haven't, we recommend you to go and see that as well, since that will be more in depth than what we will present today. But we will present the Hypermedia API and how we do mobile attestation on iOS, and we will also do a demo on this, and then in the end wrap up with a roadmap presentation on where we are on this. So let's get started. So what do we mean, Hypermedia API? Normally, when we do authentication in Curity and in other products as well, the user interacts with the browser. We call that the front channel of an authentication flow. The user starts by clicking some login button, and then a flow is driven or presented to the user. And in each step, the user has options, so they can click next, or forgot password, or enter a username password and click submit, or scan a QR code. It could be different steps that needs to be taken in order to complete the full authentication flow. And it's easy to forget that when you think about authentication, but usually it's a journey. And that means that the authentication server is driving this journey, and it's essentially moving the user through a state machine where each action the user takes is a transition from one state to another in the state machine. And this works really well when it comes to the web, because a browser is a very good client when it comes to driving something it doesn't know. It gets presented with HTML, and then the user is given the option of what should you do now? And the user understands what is rendered. Okay, there's a link, there's a button. So the user drives the browser to move to the next step, and the server then renders the next or presents the next screen to the browser, and then the user now knows, okay, now I can do this. So the browser is a great tool for this, because it can present a generic state machine flow and have the user transition between the states. So what we want to do now with the Hypermedia Authentication API is do the same thing, but without the browser. If you think of native applications on mobile primarily, which is what we'll talk about today, one of the main caveats of user authentications or problems on mobile is that a lot of these standards and flows require a browser. So you have your fancy app, and then you click login, and then a browser slides in on top and ruins the user experience in some cases. And in some cases, that browser triggers another app to open where the user authenticates and then jumps back and then back to the app. So the UX is quite poor in some cases there. And the Hypermedia Authentication API is here now to solve this. And what happens when we remove the browser? Well, we can take this whole HTML presented flow and shrink it down to the bare essentials. What do you need in order to move a user through an authentication flow? Well, you need to know what to present. You need actions, and you need links, and you need some messages. That's pretty much it in a nutshell. So we present this in a JSON format, and then the app can render its native screen based on whatever responses it gets from the server. So the server is still a state machine, but there's no browser driving it now. It's the native app. So if you write an app against our Hypermedia Authentication API, you can make it generic so that you can reconfigure the server, change authentication methods, and the app will just work because it understands the format. It understands the models that we present, not the particular screens on what each step is. And Johan will show you this further on when we move into the demo. But the browser also does a couple other things. It's not only a good tool for presenting things. If you use one of the main browsers, which almost everybody does, like Firefox, Safari, Edge, Chrome, you get protections. The browser guarantees that it will take you to the correct URL. It will redirect you if that's what it's supposed to do. It will fetch and prove that a site is protected by HTTPS or not. So there's protections here. It will serve cookies when it should and when it knows when it shouldn't. So if we remove the browser, there's some assurance here that gets lost. We don't know necessarily anymore who we're talking to on the other side. And that's where application attestation comes into the picture. Application attestation, specifically in this case, mobile application attestation, is the mechanism of figuring out or attesting that the app we think is talking to the authentication API right now is the app we placed in the App Store. So we know it's not been tampered with or repackaged, and we know that it's been shipped by us or by the third party we approved to ship the app. So we only want attested applications to communicate with our authentication API, just like we want trusted browsers to be in front of the user when they log in. And we presented last time how to do this on Android, and in this presentation we'll go through how this will work in iOS. So I'm going to hand over to Johan now, and Johan will explain more about the iOS application attestation.
Yeah, thank you, Jacob. So iOS application attestation, it's fairly similar in concept to what we have for Android. So it could be good to review that to see differences if that's something you're interested in. But in ostensibly, what we do is we use Apple's DeviceCheck Service to attest the application running on a specific device. And what that gives us for verification on the server side is basically a verification that your application, the application that's talking to the Curity Identity Server, it is the expected application that it was submitted to the Apple App Store by the expected developer, and so forth. It also will give us some information about the compile state of the application, but that's basically it. It gives us a way to tie the calling application to a specific device, or not actually a specific device, but a specific application running on a device. We can't pinpoint the device itself. Sorry. So how we do this is first we attest the device or attest the application, and this attestation object that's generated for us, it's signed by both a private key on the device itself that's safely tucked away in the secure enclave on your iOS device, and by Apple itself. So there is actually an out-of-band or on the backside, there is a request going out to Apple to so that they can actually assert that yes, this application that's running, it is something that we can trust, that it is what it claims to be. So what we do is the application it exchanges this attestation object for something we call a client attestation token, which serves as the client's credentials in the next step, which is to authenticate the client to get a access token, a happy access token, which is in the later steps used for accessing the happy endpoint. This, as you can see, so this throughout this flow, we use depop, which is a way to assert proof of possession of a private key. This private key that we're asserting, it's cryptographically bound to the attestation object itself. So the client will incorporate a signature of a public component of this key, and this private component is then used in all steps to assert that the access token that's actively used is actually part of, or that it has, the client has possession of this key, and we know that this key can't be owned by any other client because it's safely tucked away in the secure enclave on the device itself. So if we move on here, so this SDK, it takes care of all of this trickiness, or all of those steps that you saw before, to do that attestation, request a cat token, to exchange that for a happy token, and then use that happy token for every request done to the happy endpoint. All of this we take care of in our SDK for iOS, which, as I said, it's a way to neatly bind the running app instance to the current session, and all of this is used by using standards such as Auth 2 and Depop, and nothing really special here. So we haven't reinvented the wheel. And yeah, it's all provided for iOS, Android, and web. And I'm thinking we should move on and see a demo of this. So here, as I said, this SDK, it's something that we publish on GitHub. It's for iOS. It's provided both for CocoaPods and integration with the Swift package manager. We have on our Git repository a brief description of how to integrate with this and consume the SDK, the library. We provide a link in the slides so that you can get this and start working with it. So let's pop into some code just to prove to you that this really is geared towards being simple for you to use. So the SDK, it will expose a happy token manager, which is the engine that keeps the state. It makes sure that you always have a happy token to work with, and that token is well, we basically keep the life cycle of the access token. We provide a simple builder for you to instantiate this token manager that takes the token endpoint on the Curity Identity Server and the client ID as configured in the identity server. This token manager is then used to create a client, something we call a happy client. And this is what you will use in your application. Once you have instantiated this thing, you can just start making requests, and the client will use the happy token manager that created it to make sure that we put in the correct authorization headers and so forth into the requests, and make sure that everything just works for you. So let's take a look at this application in a running simulator. So here we have the client, and when I start the authentication flow here, what will happen is we will use the happy client as you saw before, and just make an initial request to the happy endpoint, and then the token manager will take over. It will see that we don't have an active authorization access token, and we need to get one. So it will drive the attestation. It will make sure that we get this token and then insert it into the request that was just made. So let's get on with it. And so here we see now we're authenticated, or the client is authenticated at this point. It has its access token for use with the HAP API. We under the surface here, we got a redirect that to a model, something we call a representation, that tells the client that you have 3 authenticators for the user to select from. The client here is not very smart. It's basically like a web browser. It doesn't know that this is a list of authenticators. It doesn't have that context. All it knows is the server told me to show a list, and I'm going to show a list. So let's pick one of these authenticators. And once again, we're shown a form. We're expected to enter our username. The app itself doesn't know what a username is. It only knows that I'm supposed to show a field for the end user to enter something into. And all the labels, everything is just, even the button, the next button here is provided by the server-side state machine. So I try to log in here, and here, once again, I'm presented with a list. This time the list looks a bit different. That's because the server has the ability to send somewhat more complex hierarchical options to us. So here, for instance, we have a list of options that have sub options. So I can go in here and see that I have 3 sub options and a 4th even sub option that itself is a sub option. And since when I'm clicking around here, I'm actually never communicating with the server, that's why I can go back. And this is behavior that's driven by the server itself. So it is basically the authenticator that decided that this is the behavior I want the device to have. So that's the behavior that we see in the device. So let me continue here. The authenticator, which I missed to tell you that I've selected, it's called Duo. It's a 2-factor authentication method, and it allows us to pick up different ways of authenticating user. Push notifications, SMS, or a one-time password. So I'm gonna select the push notification just to show you that, because when you're doing push notifications, the client needs to wait for me to enter some information into a second device that I have that's coupled to Duo. And so then the server will have a polling experience presented to the user, and the app will make sure that happens. And this is where the app itself has some intelligence, because it knows here that I'm doing polling, so I'm going to automatically submit periodically the forms that I'm given by the endpoint. So now I'm going to approve the authentication on my second device in Duo, and here we can see that the polling finished, and we are handed a authorization code, which the device, this is just for a presentation, because this authorization code the application will then use to exchange for an access token to whatever API that it is you actually want to talk to. So let's look at some of the configuration for this. So here we have the client, the configured component for the client that we just used. We can go down here and see on client application settings, that we have a new section called Attestation that's enabled here, which tells us that this application can authenticate itself through attestation. And we have the type is iOS, which means that the server knows what type of attestation object to expect from the client. It is tied to an Apple ID. This is the data that we pull from the attestation data that we're handed in the initial authentication of the client. This is asserted by Apple that this device is running this application and it can only be this application. No other application can have this app ID. So this is something that you're required to enter when you configure a client for use with Happy for iOS. We have here we have the option to disable attestation validation. This is strictly for development, but it's very useful for, as you saw, for instance, the application is running on a simulator, and during these circumstances, Apple doesn't allow you to use the attestation framework. So here, as you're developing your application, it's very useful for you to enable this. And this means that the entire flow that was previously described, we're still jumping through all the hoops. The only thing that we're not doing, we're not validating the attestation, because there is no attestation when you're running a simulator for iOS. So we can see here also that we're using a specific policy. And if we take a look at that policy here, this is something that you can apply to all of your, if you have multiple clients, then you can supply the same policy, use the same policy for all of them, or a subset or a collection of policies for certain devices, depending on what it is. So here, for instance, you have the option to select the mode for your client, and now it's non-production. This is part of the attestation object. So in the attestation, it will have the information that this application is compiled for development or it's compiled for production. And since this was for development, it's non-production, the option that we've selected. If you picked wrong here, attestation validation would fail server-side. We also give you the option to change the certificate chain validation, which in most cases, you should not need to change this, but we supply it anyway under this happenstance that, for instance, Apple's root certificate is compromised and they need to change it, and we don't have the time to supply an update of the identity server, then you can modify this yourself. So let's go back to the client itself and see here that
the attestation configuration that you showed there, the policies and all of that, that was available for Android in 5.3 and now for iOS in 5.4, but it wasn't available in the UI until now. So the whole UI structure of this is new in 5.4.
Yes, exactly. The UI is new. Here we can see the three authenticators that the client is allowed to use. And we saw those in a list when we first used the client. And what I'm gonna do here is remove two of them and commit this. And now if we go back to the client and we restart our authentication, we are immediately presented with the form for the simple username password authenticator that was left of the three. I removed two of them. The reason for this is, well, this is how the identity server behaves. If you only have one authenticator, there is no need to provide you with a list. So it won't provide a list of authenticators to the client. It will immediately jump you into the authenticator itself. And that's what happened here. And if I log in here and omit the password field, we can see that just as for a web browser, I submitted a form. The server had a requirement for me to enter a password. I didn't. The server will tell the client, and the client can do this. Can show you what was wrong. The client itself didn't know that this was a required field until the server told to. So if I authenticate here, now the server is happy again, and it authenticated the user, and I got my authorization code. And that is it. That's an overview of a very, very, very simple client that has no context for what user authentication actually it is. It just goes through the motion that the server tells it to do.
Very good. Thank you, Johan. So let's continue with the wrap up. So what this was now that we presented was the iOS driver SDK, we call it. So it's a low-level SDK, and now we have it available for Android, iOS, and web. And what this is, it wraps all the security measures that are needed in order to communicate with the Hypermedia Authentication API into a driver that you can communicate with. So essentially a web client that you can use. So it's very convenient in that sense. However, it means that there are things on top that you need to be able to add. And we plan to add more utilities, model helpers, and other utility tools as SDKs on top of this next year. And on top of that, add presentational SDKs such as a React application SDK or similar, depending on platform. So there'll be more coming, but this is the sort of cornerstone or base layer in every platform that is needed. And now we've completed that with iOS. So we have fulfilled the plan for mobile and web with this. So this roadmap that's been presented before, just wanted to show you the update. We released version 5.4 in November, or 1st of December, actually. It is now feature complete when it comes to the SDK models and the structure. So we have the first release candidate out, and we had planned for an 5.5 which would be a second release candidate, which would contain the web SDK. But the web SDK is already done and was released now in 5.4 as well in its final version. It's been presented before, it was just now finalized. So we will not release the 5.5 RC2, but instead we will ship additional docs and examples in between 5.4 and 6.0 on our website. So keep an eye out for that in the resources sections, as we usually publish guides there. 6.0, the GA release of the Hypermedia Authentication API and these SDKs is still planned for February. And it will contain what you've seen now. It will also contain, be feature complete on all authenticators, all actions that we ship will support authentication, registration, and action prompting, and so on in this 6.0 release. So that will be the stable version of the API. We don't see any bigger changes to the API itself now since RC1, but GA is pretty close. That's it. Let's see if there are any questions. I haven't seen any questions so far. So if there are not anything else, we will wrap up, and thank you for joining today. And keep an eye out for more material showing up on our website. And you can follow us on Twitter at CurityIO or email us if you have any questions. Thank you for listening.